In this video, we're going to be looking at AN5, rational operations on rational expressions. So first thing I'm going to do is determine the difference between these expressions and any non-permissible values. All right, so I am subtracting two fractions. Sure, the fractions have a bunch of noise going on there because they're expressions, but at the end of the day, I just have to follow my fraction rules. So in order to subtract things, I need to have the same denominator. And I notice right away, hey, they're the same denominator. Just like I know that 1/2 plus 7/2 is equal to 8/2, because I can just look at the numerators, I can apply that same principle there. Some of you might be saying, wait, Savoy, can't I just cancel those out? You know what? I could, but there's not really any point, because then I get into the situation where I just would write a 1 here, and that means I don't have the same denominator anymore. And I would just immediately reverse engineer it and be multiplying by x minus 1. So if on the exam you see something that's already given to you with the same denominator, say, awesome, thank you for saving me that extra step, which can be quite difficult at times. So I'm just going to literally write this as one giant fraction and say 2x minus 3 minus, and then I still have the x minus 1 in my denominator. I'm going to put brackets around here to remind myself that this negative distributes to everything, okay? I am minusing this entire fraction, so I have to minus this entire expression here. All right, and I can just write one denominator because it's all over that. Okay, I'm talking the same language, right? Like you can imagine I'm talking the x minus 1 language. So this is over x minus 1, this is over x minus 1. I can just write the whole thing over x minus 1. Next, I'm just going to say, there's a couple ways you can do this. I can do this one step, but you know what? I'll break it up into two. You guys are watching this probably because you want a little bit of help. So I'm going to distribute this negative to both terms. So I'm minusing x and adding 1. And then it's over x minus 1 again. And now I'm going to group like terms. 2x minus x. Okay, so I'll highlight these. So the 2x's and the x's and the negative x are like terms. So 2x minus x just gives me x. Negative 3 plus 1 gives me negative 2 all over x minus 1. If I could factor and try to cross things off, sure, I would try. But this looks, there's nothing else to do. I've got a linear expression over a linear expression. Check, I am done. Just kidding. I also need to do NPV. So I go back to my original and I notice that, okay, it's the same thing both times, which is chill. So I'll say x minus 1 cannot be equal to 0. X then cannot be equal to 1. So again, I have an expression now, just like what I had above here. So I had in this outcome, I just started with an expression. And these ones, I'm getting to the expression. But at the end of the day, the same principle applies in terms of non-permissible value. My x can be any value except for 1 in this particular case, because I end up dividing by 0. All right, let's go down to this one right here. Same thing, except it's going to be a little bit more challenging. As I mentioned before, as we progress through questions on a page or questions with an outcome, they get more and more challenging, okay? So here I don't see the same denominator. You might think I'm really close, but in fact, this is a difference of squares. So I would personally think of this. I'm just going to kind of cross this out here and write what it equals right underneath. This is just going to be x minus 1, x plus 1. Okay, so in order to get the same denominator, I need to have the exact same thing under each one. Okay, so I need to have the same denominator. Okay, so which means I need to have the same pieces. So I see that this one has an x minus 1. This one has an x minus 1. All right, this one has an x plus 1. This one does not. So I'm going to add in the x plus 1 to the denominator and to the numerator. Okay. The reason this works is because I'm essentially multiplying by 1. Okay. This is just 1 right here, right? X plus 1 over x plus 1 divides out and gives me 1. So I haven't changed the value of the expression. What I've done now is I've allowed myself to be able to put them together. So I've got x plus 3 plus x onto x plus 1. And I'm just going to write this as one fraction now because they both are made up of x minus 1, x plus 1, x minus 1, x plus 1. And now I'm just in the job of simplifying. Okay, so x plus 3 plus x squared plus x over x minus 1, x plus 1. I have a lot of students that want to multiply this in. There's nothing wrong with it, but my advice is always to leave it factored. For a couple of reasons. One, we might get to a point in the last step where we can factor everything and cross things out. So the work's already done if we leave it factored. And the other one being it's just kind of a waste of time. Not a waste of time. I hate being so negative, but it's not an efficient use of our time because the goal of this is to be able to put it into one fraction and kind of simplify it down. and that's kind of already being done right here. So if I spend time foiling out or distributing out there, it's not the greatest use of time on a timed exam. So I've got x squared, and then I'm going to look for my like term. So x and x gives me 2x, a positive 3 over x minus 1, x plus 1. And you might think you could factor because you're like, hey, 3 and 1 is a difference of 2, but everything's positive here, and there's no way for me to get down to a 2 with a plus 3 and a plus 1 or a minus 3 and a minus 1, so it's not factorable. So that's as simplified as I can go. I'm going to write the MPVs just right here. And so I would say, all right, x minus 1, x plus 1 cannot be equal to 0. And then I would say, okay, x minus 1 cannot be equal to 0, x cannot be equal to 1. And almost them just kind of like the mirror right here. X plus 1 can't be equal to 0. X cannot be equal to 1. Negative 1, excuse me. I could have done this as like even two distinct statements and kind of going back to the true original. But at the end of the day, everything has an x minus 1, x plus 1. So it was fine just to kind of write it as this. And that's what the final expression simplified down to. And I didn't cross off anything. So it was fine for me to use that. All right, let's look at this big guy right here. So I'm going to simplify and then divide. I'm going to kind of just go over here and just factor everything. All right, so I'm going to have x plus 7, x plus 1, all over x minus 7, x plus 1, divided by x plus 6, x plus 1, all over x minus 7, x plus 1. All right. So I'm going to make a little star here and talk about NPVs. Okay. So if I'm thinking about NPVs, non-permissible values, the division ones are the trickiest. Okay. So I'm going to start underlining all the things I have to think about with NPVs. So I'm going to think about this for NPV. I'm going to think about this for NPV. You guys are probably okay. Gotcha Savoy looks great. I'm also going to think about this one and think about this one. And again, you guys are probably all thinking, all right, awesome. I also now need to think about this one and this one here. And I might have lost some of you there being like, whoa, Savoy, why do we care about the numerators? Normally we can have 0 on our numerator and things are fine. You can take 0 divided by any number and get 0 out. 0 is a number. We can have that as an answer and have it in our numerator. What I can't have is 0 in my denominator. And you have to remember that this whole right side here, this is a denominator, okay? So I have to keep in mind that nothing can equal 0 here because this is all multiplication / division. So as soon as I get a 0 somewheres, it's like a bad apple. It just affects everything else, and I end up dividing by 0 because I'm dividing. So I'm dividing by something. Remember, I cannot divide by 0. So, and I'm willing to bet you guys are pretty good at this, so I'm just going to start stating stuff. So x cannot equal 7, negative 1, 7 again, I don't have to repeat myself, negative 1 again, I don't have to repeat myself, negative 6, and negative 1, I don't have to repeat myself. So there's only 3 MPVs. However, I had to look at all the different factored stuff in each, down here just like normal, down here like normal, but also this numerator. Okay, that only happens with division, but it is something important to remember. Now I'm just going to keep going. And so if I can simplify something right away, I'm going to simplify something. So I see, hey, these simplify. Awesome. Did I mean to pick that color? No, cool. And then I'm going to keep going. And I'm going to write, okay, x plus 7 over x minus 7. When I'm dividing fractions, I can multiply by the reciprocal, otherwise known as keep, change, flip. And I can multiply by x minus 7 over x plus 6. And when I put these together, remember, multiplying fractions is chill. You just smush them together. So x minus 7, x plus 7, and x minus 7, and then x plus 6. And then the x minus 7s cancel, and we are left with x plus 6 over x plus 6 x plus 7 over x plus 6 is a final answer. Okay, simplified all the way down, non-permissible value stated. Awesome. All right, that's it for this video, and I'll meet you guys in the next one when we'll be tackling rational equations.